right, so today I'm going to be talking about Minerva, which is Airbnb's metric platform. So specifically, I'll be discussing 10 problems that Airbnb solved by building Minerva. So a little bit about me. I'm a senior software engineer at Airbnb. I am a 6th generation Oregonian, so I live in Portland, Oregon in the United States. Working remotely, Airbnb is based in San Francisco. And I'm on the metric infrastructure team. So we're responsible for the development and the operations of Minerva. Awesome, so for the agenda today, I'm going to talk a little bit about the history of data at Airbnb. Then I'll talk about the 10 problems that we encountered with our previous data architecture. Next, I'll go over what is Minerva and how does it try to solve these problems. I'll give a case study for how Minerva was actually used to help Airbnb figure out its strategy when the pandemic hit. I'll talk a little bit about how we deal with change, which is a constant factor for many businesses and data platforms. And finally, I'll revisit those 10 initial problems and kind of map them to the things I was discussing afterwards. So cool, the goal of this talk is for you to recognize the problems that I'm talking about at your own business or institution. So hopefully you can kind of see the issues that come up and say, oh, hey, yeah, at my company, I ran into something similar, or we have the same problem, and maybe get some insight for how it could be solved for your organization. Awesome. So I'm going to start with a brief history of data at Airbnb. So let's go all the way back. Airbnb was founded in 2008 during the recession. And by 2010, there was only one full-time data analyst at the entire company. So his laptop was the entire data warehouse. Back then, queries were run against the production database. And if a query took too long, it could cause an incident which would bring down Airbnb.com. So obviously the state of data at Airbnb was it was pre-Cambrian back then. All right, so by 2015, 5 years later, Airbnb had grown very significantly and the infrastructure had matured. So I don't know if any of you use Apache Airflow, but that was a project that initially came during this time period at Airbnb, and we used to solve some of our workflow orchestration issues. We also invested in core data, which is a set of highly critical tables I'll discuss in a little bit. We built an open source Apache superset, which is a charting open source project which you might use at your companies. And we built and scaled Airbnb's experimentation platform, which helps do A/B testing. We also built an internal data catalog called Data Portal. So back in 2015, this was the bird's eye view of our data warehouse. So starting from the left side over there, you have your raw data. So events, logging, third-party data. And to the right of that, you have the core data tables. So you take these raw events and you turn them into facts. So like, when did bookings happen? Or dimension tables like listing information. And then there were a bunch of tables built off of those that were, your fact tables merged with your dimension tables, kind of an explosion of complexity of different tables that were derived from those kind of core set of tables. Complexity got even greater and greater with fact tables with more and more dimensions, and finally all the downstream tools that powered things like superset or A/B testing or financial reporting were built on top of these pretty complex tables. So this isn't a great system, and the reason is because it's very hard to reason about this part in the middle. So as you build tables that are derived from your fact or dimension tables, you have a lot of different tables that start to proliferate, and so things change. Or if people leave the company, suddenly things are left in a state where you don't really know what's going on. And a lot of organizations run into this problem that as their data scales, if it's not managed properly, it becomes a bit of a tarball. So, with more and more tables, people were starting to report different numbers. So one team would be asked, how many users were in China during this period, and they would give an answer. And another team would run some queries and give another answer. And the reason was because there's some subtle difference in how the tables were defined. Or someone fixed a table and it didn't propagate all the way through all the things that depended on that table, and then suddenly the answers were different because there's two different versions that were conflicting that nobody was keeping track of. Data issues are hard to debug. People only have a certain amount of RAM in their head, so you can't fit the entire state of the data warehouse in your brain. And so when something goes wrong, being able to reason about it is really important. And if the complexity is too great, you can't do that. So essentially what happened is data scientists were starting to second guess their own data, data quality was starting to fall, and frankly leadership was not trusting the answers given by the data org because of problems like this. So there's a story of the CEO, Brian Chesky, asking some question, and it took like a week to get the answer, and he got two different answers. So it was really messy, and even though we had all this great data tooling, we weren't really able to generate the insights that we wanted to generate. Okay, so taking a step back, let's think of 10 concrete problems that we had with our data architecture at that point. And please, if you can see any of these in your organization, write it down, think about it, and try to map it to later on in the presentation when I talk about how we solve these problems. Okay, so the first problem was that data assets didn't really have clear ownership. So I'm sure you've been at a company where there's a reorg, and suddenly the people who own an asset leave. Well, who owns the metrics, the tables that power those metrics? It starts to get very confusing. And 3-4 years down the line, there's drift. No standard tables for data tooling to work off of. So often, I've worked at some companies where data tooling was like siloed between teams. And so one team would have this table that they use for metrics, but then another table has another table, or another team has another table they use for metrics. And all this drive data gets duplicated and complexity starts to increase. The third problem is that drive tables don't always update when an upstream table is changed. So, for example, let's say Airbnb decides that they're changing how a reservation defines whether it's booked or not, or whether there's availability. Well, they change that data model, and then suddenly everything that relies on that table needs to change. If you don't have a way to do that automatically, then suddenly you run into really big problems. Data assets siloed across teams. So in the past, I worked at Tesla, and there every team had their own data assets. And essentially, if you wanted to share with another team, it was a huge process, and because of that, like nothing was shared. There's no easy way to group or filter existing metrics by arbitrary dimensional cuts. So let's say you have some metric like bookings, and you want to see, okay, what are all the bookings from users from Poland that are booking in Hungary? Well, how do you do that without having to go to these new tables and join them in and do a lot of work? There's no easy way to do it. Inconsistent and undocumented data quality. This is a huge one. So maybe a table is bad, and the people who write the table know that there's data quality issues, but they don't tell anyone, and suddenly people are using the data downstream. Or even more nefarious than that, someone writes a query off of a good table, and the query is incorrect, but nobody is actually validating it, and so it goes into reports downstream. Users cannot easily test how changing a table affects downstream tooling. So the example I gave earlier of changing how we define whether Airbnb is available, if you make that change, how do you make sure you're not breaking everything downstream when you actually tweak the definition of that metric? So data assets not properly cleaned up. This is a huge one. So if there's a reorg or a business vertical that stops existing, all those tables just sit there forever, and nobody's looking at them, nobody's cleaning them up. There's still dashboards using that data, and it's still just sitting there. So it's very operationally hard to manage data that changes. data is very expensive. You're running all these pipelines that are constantly computing. So how do you know how much things cost? And finally, is there a central place for people to find answers to business questions? So these are a lot of issues that we're running into. And we kind of were thinking about all of these and thinking about ways to solve these problems, and we came up with a metric store, which I'll talk about in a second. Okay, so Minerva overview. Before Minerva, this is what the bird's eye view looked like. You had your raw data, you had your core data tables, which were derived from that raw data, and then a mess in the middle, frankly, and then you had all this downstream tooling. So Minerva is a platform that allows users to define once and use everywhere. That's the main value proposition. So our data architecture looks more like this now. You have your raw data, like event streams, logging, etc. Then you have your normalized upstream tables, like
bookings or bot detection or device mapping. And then Minerva is kind of this black box that sits in the middle here. And all these things like A/B testing and executive reporting and Tableau sit after it. So how does this work? All right, so the main tool that we use is this kind of old pattern in data warehousing called star schema. I don't know if any of you have heard of this before, but it splits tables into two types. The reason it's called a star is because the center of the star is this fact table, which is facts about your business, so like booking information, measures. And then you have dimension tables, which are things like listing information. So where is that listing? What region is it in? What's the host type of that listing? And when you do some sort of business or OLAP query, you join these tables together and you write a query on it. So essentially, your fact table has a bunch of measures, and then the primary keys of other tables are pointed at. And so when you're trying to cut bookings by which region it came from, you join these tables together, and then you do some sort of aggregation. So this is the kind of the fundamental unit of Minerva, is these fact and dimension tables, which we call measure sources and dimension sources. So they are reused across the entire company. We have an entire org of analytics engineers, and pretty much these analytics engineers, one of their main jobs is to manage these fact and dimension tables and make sure that they're high quality. So every single one of these tables has clear ownership. So there is a group that owns each of these tables and makes sure that as data models change or as the business kind of drifts over time, there's still a point of contact for every single one of these. OK, so what do these actually look like? Just a little bit of code. You have a configuration. For example, here it's burger source. It's data about my hamburger sales. So is incremental means that every single day, new data lands in the fact table here. So this is the SQL that generates the actual fact table, and the upstream data, those kind of curated tables, are the inputs to this. So facts sold items would be the fact table upstream. And the measures, or the facts in the fact table of star schema, are defined. This is one example, but here it's burger count and drink count. So below this, you can define a metric. You can say, OK, how many burgers have we sold? Well, the burgers sold is a sum over burger count from this table that is defined above. All right, so this is kind of what the data warehouse starts to look like when you use this pattern. You have your dimension sources, which are things like listing location or listing type, user location. You have your measure sources, which are your fact tables. And then you have dimension sets. So what is a dimension set? Well, let's say you want to cut bookings by a listing and a registration status. If you need to do all those joins on the fly, it can be really expensive. So we pre-compute certain combinations of metrics and dimensions, and that's what a dimension set is. OK, So let's say you want to answer a question like, how many bookings at Airbnb happened in Hungary with users from Poland, and I want to filter it by whether or not they're a superhost. So you can answer this kind of question ad hoc using this kind of system. So Airbnb has a web portal called Data Portal, which is like our one-stop shop for being able to query data, dimensions, et cetera, at Airbnb. So let's say I'm curious, I'm someone internally, and I want to know about bookings. So you just type in bookings in Data Portal, and you can see right here there's a Minerva metric called bookings. Notice this little gold icon here. That's called MEDIS certification. I'll talk about it in a little bit. But we have this entire process of making sure that data is high quality, certifying it, making sure people are looking at it as data quality checks. And it essentially means that when you're looking at this metric, you can have confidence that the data has been looked at and vetted. OK, so this is what Metric Explorer, one of the UIs, looks like. And essentially, if you want to look at some metric, it gives you a time series. The bottom line is actually a year-over-year analysis. That is just by default. You can see that there's maybe some sort of weekly trend in whatever metric this is. You can group by, you can filter, you can do all this ad hoc analysis just by playing around with the UI here. You can also get a link to Superset, which is our charting library, if you want to drill down even deeper into these metrics. So importantly here, if you look, you can see there's a metric owner. So this is super important if you want to, if something looks wrong, or you want to talk more about how this was actually defined, you can just click on this person's name, and it'll give you all their information, and you can strike up a conversation and talk about how this metric was generated. You also have MEDIS models, which are like which sub-org is in charge of the data quality for this particular metric. You can also see things like landing times, like how long on average does this table take to run? Is it typically delayed? There's a lot of information you can get about the metrics through this UI. The nice thing about this is to reason about a metric, all you have to do is reason about the measure and dimension sources used to generate it. This is like the key insight that has allowed us to scale Minerva really significantly, and I'll talk about the numbers in a second. But the whole point is that if you have clear ownership of metrics and dimensions, it's easy to maintain your data, it's easy to verify that things are correct, and it's easy to trace the history of a data asset over time. All right. So let's talk about the numbers. There are 38,000 metrics at Airbnb. We have over 20,000 dimensions. We have over 5,000 tables and over 6 petabytes of data. So that's a lot of data. Frankly, this wouldn't have been possible in a pre-Minerva world because the complexity of doing analytics at this scale would have surpassed the number of people at our organization pretty quickly. It was already starting to do that in 2015. But with a model where you can trace every data asset, it becomes much easier to build a large corpus of knowledge. OK, so then downstream of Minerva, I'm not going to focus as much on this during this talk. But you have dashboarding, you have Metric Explorer, the UI I showed earlier, you have experimentation, Tableau, et cetera. And we have an API that all these services can ping. And it just gives them the metric and dimensional cuts and the owner and all that information just through this API gateway. All right. So I'm going to do a little bit of a case study. This is something that really happened at Airbnb in 2020 when COVID started. OK. So historically, before the pandemic, Airbnb has been split between urban and non-urban destinations. So for example, when I go on a trip, sometimes I'll go to Paris. Sometimes I want to go to a cabin in Oregon. And statistically, it was split pretty evenly between the two. But when the pandemic started, there was an aversion to going to cities to travel. And that was a hypothesis that one of our data scientists had. And anecdotally, that's what I did. I was only going out to cabins during the pandemic. So the hypothesis was that travelers would avoid large cities in favor of destinations where they could keep social distance. OK, so how do you actually confirm this hypothesis? So we already had a nights booked metric, and you can search it in Data Portal. It's front and center. So she knew this existed. But the dimension that she cared about, whether or not a listing was urban or rural, wasn't something that was easily accessible. So how do you actually get that information? So what she did is she used an external data source, the Global Urban Rural Mapping Project, and some NASA data, and she was able to create a table that was the input to Minerva. And she called this new table dim listing urban category. And it gets ingested into Minerva through that config that I was talking about earlier. And the Minerva definition is pretty simple once you have that upstream table. So this is a dimension table. This is the dimension source here, dim listing urban category. And when you put it together, now you can cut the nights booked metric by this new dimension pretty easily. You just define your metric, you commit it, and it will just suddenly exist. So now, if you look at the nights booked metric, you can say, OK, let's group by urban category. So is it high-density urban? Is it low-density urban? Is it non-urban? Do we not know the answer? And you can see that before the pandemic, non-urban was actually the most popular, just by a little bit. But after the pandemic, there's a huge stratification. And it turns out that people really wanted to go to non-urban Airbnbs somewhere out in the forest during the pandemic. So using this information that we were able to get really quickly with Minerva, the business actually changed strategy pretty quickly, and Airbnb started promoting more and more non-urban listings. So this is just one example, but there are literally hundreds. And Airbnb used Minerva data really, really heavily to quickly iterate on dashboards, et cetera, in the wake of the COVID-19 pandemic. And some of the most viewed ever dashboards internally are from this time period. OK, awesome. So the next thing I'm going to talk about is change, because change is really, I think, the most complex and difficult part of managing a data ecosystem. So what happens when a table changes or is delayed? So for example, let's say revenue comes from an upstream source, a cluster went down, or some data was wrong, and suddenly you need to change something, and it needs to propagate all the way through your data warehouse. How do you deal with that? OK, so in Minerva, we have a very simple API to be able to backfill your data. You can just go in a notebook, and you can say minerva.backfill. You can say a start date and an end date and the data sets that you want to backfill. And what it'll do is it'll just spin up an Airflow job with the data you want to change. It will compute the new data, and as soon as you merge it into production, it'll just swap it atomically, so you'll be able to get the new data right away. So this is a very simple interface, but it hides a lot of complexity behind the scenes, because there's this entire graph of dependencies for data assets, and Minerva just kind of behind the scenes handles swapping everything out, cleaning up all of the old tables, changing all of the dashboards to point to the new data. Everything is just done kind of transparently for you. We have two types of backfills. We have online backfills, which is like you change the entire definition of something, or an offline backfill, which is, an online backfill is when there's like a partition missing and you just want to regenerate it. An offline backfill is when you totally change the definition of your data. Both have the same interface. You just say backfill, and it'll automatically do it for you. You can click on an Airflow link to actually see the jobs that are running, but that's just kind of a data engineering detail for people who want to see their data progressing. We also allow people to test changes through an API we call dry run. So let's say I change the definition of a source. Well, maybe a lot of dimension sets, dimension sources are affected by that. We tell you exactly what changed. We have cost estimates. So this is like an entirely different part of the system. We figure out, based off of AWS cost data, the historical cost of making a change like this, and we give it to you right away so that you don't accidentally make a change that costs a ton of money. And you can dry run it, so it like samples the data. It gives you what your data would look like if you made this change, but you haven't actually made it yet. So there's like backfilling, and there is testing changes. One of the kind of fundamental things that allows us to do this is this idea called data versions. So this is going to get a little bit technical, but imagine your data assets are like a dependency graph of different like event sources or measure sources or dimension sources and dimension sets. When you make a change to one thing, everything kind of breadth first search from that asset needs to also be changed. So what we do is each object has what we call a data version, which is like a hash of its important fields, and then also a hash of the things that depend on it, or that it depends on. And so when you make a change, it will automatically propagate down the entire graph and recompute everything that was touched. So this is the system that we use to kind of automatically change the state of the entire data warehouse when some definition changes. This automates backfills for us, and it ensures consistency. So the state of the data warehouse will always be up to date with the current state of the configs in production. And when you make a change, it will just, you'll never have two versions of the same table together in production. All right, so we also ensure that analytics engineers or data scientists or data engineers, the people who are in charge of defining these dimension sources, defining these measure sources, that they test everything. Because if you want to have confidence in your data, you need to make sure that there's data quality checks. You need to make sure that a human looked at it, that it looks correct, that maybe multiple teams have actually taken a look at it. And so we have a very strict flow for how to make changes. So we have automated data quality checks. We do sample data validation. Users have to put things up for code review, and we have automatic SOX approvers. We have a very strict system for making sure that when you make a change to some data asset, it actually gets, people actually take a look at it. And only after it's passed code review and people have looked at your data does it actually become backfilled. So this system allows us to have Midas certification, which is what I was talking about earlier. It's our analytics engineering system for making sure that data assets have passed thorough checks. So if you're looking up a metric in like Data Portal, the thing I was talking about earlier, it prioritizes Midas certified data sets so that when you're looking at something, you're more likely to be shown something that is being monitored and being checked for data quality. So if you're interested more in that particular section, we have a blog post from 2020, Data Quality at Airbnb, which goes into Midas certification and how it fits in with Minerva, and you can get more context there. All right, so let's go back and talk about those 10 problems that I discussed earlier, and I'm going to map them to all the things that I discussed in the previous section. All right, so no clear ownership of data assets. How do we solve this? Well, the star schema means that you can break everything into dimension and measure sources, and everything is a point of contact. So even as there's reorgs, people come, people go, everything needs to have an owner at all points in time. And so it's great because if something goes wrong or something looks incorrect, you can always find a point of contact for every metric. No standard tables for data tooling. Minerva is a single source of truth. We are the gold standard tables, and pretty much every downstream application of data at Airbnb, or most of them, use Minerva data. Derived tables do not always update. Well, so this whole dependency graph stuff I was talking about with data versions, that is our solution to this problem. We essentially enforce that the state of the data warehouse is always up to date with production configs. So you're never going to see like listings v1, listings v2, and then tables in your data warehouse that are some combination of them. Like we make sure everything's very clean. Everything is always based off of production data. Data assets being siloed. Data Portal allows you to search for different data assets, metrics, et cetera. And it's really fostered a culture of collaboration across Airbnb because pretty much everybody goes here to look for data assets, and it's very easy to find them. No easy way to group or filter existing metrics. Well, that's kind of the whole benefit of star schema. It allows you to do these OLAP workflows with group bys and filters very efficiently. And so you can just use our API. You can go to data portal. There's a lot of different ways you can access this data as long as you have the correct permissions. Inconsistent undocumented data quality, well, Midas is our solution for that. We're actually working on even more than this kind of going forward, but that's a story for another time. But Midas is the data quality project within Airbnb that allows people to have confidence in their data. Problem 7, users cannot easily test how changing a table affects downstream tooling. So like if you're changing how listings are defined or something, how do you get that to go to all the downstream dashboards? Well, dry run will just do that for you. You say dry run with your changes, and you can actually see in the dashboards downstream what they would look like given your change. It's pretty mind-blowing when you use it. Data assets properly cleaned up, littered with stale tables. This one has been pretty much completely solved as long as you're within the Minerva ecosystem. If you backfill something, it will automatically clean up all of the tables from the old state of the world as soon as you merge in your changes after a backfill. Consistent alerting cost data. We have, because the Minerva team or the metric info team manages this entire ecosystem, we can get cost data for all of these DAGs that generate this data. And we have a bunch of tooling that allows you to very quickly see how much it will cost to backfill or make changes to data assets. So very nice. It prevents people from blowing everything away and spending a ton of money because they get blocked if it's over a certain amount of cost. And then also, you can always point to the owner of a metric or a source in order to flag things that look wrong. Finally, no easy place for everyone at Airbnb to find answers to business questions. The Minerva API powers all of these downstream tools, and a lot of them, like Metric Explorer, make it really easy to find answers to various data questions you might want to know the answer to. Awesome. Thank you very much. Hopefully this has been interesting, and if you want to connect with me on LinkedIn or talk with me after the presentation, I'll just be around here, and I would love to chat. Thanks.
Excellent. Thank you very much. I love the COVID data visualization. It was such an interesting hypothesis, no? I see a lot of comprehension and a little bit of desperation. I hope you guys send a lot of questions. I will also remind you that if you would like to rewatch some talks, they will be soon available on YouTube. And also through Slido, you can rate the performance of our speakers. So please, if you liked especially Philip's speech, you can rate him 5 out of 5. Thank you very much. So let's go to some questions. I will read them out for you. All right. Is Minerva available for the public? All right, take your time.
Good question. So Minerva is not open source. There have been conversations about that internally, but that's something that I think is being left for the future. So I can't really give a better answer than that at the moment.
Excellent, thank you. It seems you're using YAMLs. Did I say it correct? For the Minerva config. Did you manage to, oopsie daisy, did you manage to run into any issues with it?
So yes and no. YAML is useful for us because we use Git to resolve conflicts and to tag the correct reviewers. That's kind of one of the important things about Minerva data is that the right people are looking at things when they change. So currently, our system is built off of YAML configs and GitHub automatically tagging the correct people when a change is made. We're looking into other ways of representing this information. We're building a UI for our metrics layer. And so I think this is in flux. Maybe a year from now, we won't have YAML anymore. But at the moment, YAML has been very useful for us. We haven't really run into the limitations of YAML as like we're not using TOML or anything. That's not something that we're looking at the moment.
All right. The metrics owner is a business person or from the IT department? Please provide some further information about metric owners.
Yeah, so Minerva's kind of taken over data at Airbnb, so there are people from pretty much every conceivable part of the company who are interested in accessing data. There's business analysts, there's analytics engineers, there's data engineers, there's software engineers. So it's not just business users, it's users of all kind of the spectrum of technical strength. And I think that's something that's been really nice because everybody has the same information that they're using to make decisions.
Great. During data validation, is data being validated against the source or just a previous layer as raw?
That's a good question. It's not against the previous version of the data because someone might change their data model so significantly that the data looks very, very different. So users can define custom data quality checks. We also have like great expectations and libraries that we use to have predefined checks. But in general, it's not against the previous version of the data. It's against kind of arbitrary data quality queries a user might write or share with other Minerva users.
Thank you. We have time for a couple of more questions. So why did you decide to create Data Portal? Is it because your non-tech colleagues also found Superset hard to navigate, or is Data Portal easy enough for them?
Data Portal allows you to find data assets that you might not otherwise know about. So Superset is great for drilling into a specific metric, grouping by things, creating charts. But if you want to answer a question really, really quickly about a domain you know nothing about, you can just search the metric on Data Portal or search a team on Data Portal and find it. So it's really for data discovery. And then it links out to all the other tools we have to drill in more. But that's the main value add. There's also more than just metrics in Data Portal. It's like tables and SLAs and teams and all these different things. So it's more about finding things than doing deep analysis.
You're right. Aren't 30K of metrics too many to be looked at for the business? Never too many metrics. Are there plans to simplify?
That's a really good question. I think one of the difficult things about metric stores in general is that it's much easier to add than it is to remove. So we have systems for essentially looking at usage data for metrics, and we try to clean things up as they go. But maybe something's used in one dashboard that's only looked at every few days. Pretty much the entire company is using Minerva and constantly adding things. And so that's where the 30K number comes from. We have hundreds of people using Minerva pretty constantly for their job. I think the analytics engineering org is the one that we work with to kind of manage the state of the data ecosystem. And I think there are efforts to reduce the amount of data swamp or cruft that has accumulated and kind of have a set of like very important high-quality data assets.
All right,
Yeah.
Let's do the last question. Guys, if you have more questions, I suggest you find Philip and grill him on all the Minerva topics. So how much effort was that to migrate existing flows to Minerva? Was automation possible?
Yeah, it's funny because before Minerva, there were like 5 different teams that were doing like subsets of what we do. And you would think that it would be really difficult to migrate a lot of their projects to Minerva, but it's actually not very hard because all you have to do is write SQL, put it in dimension and measure sources, and then you get all this stuff for free. And so we found actually that teams that migrated to Minerva could do it pretty quickly, and they just like tore down their old systems because it's nice to have a single source of truth for everyone. A lot of things have already been added. We had a lot of tooling already set. And so I don't think we had very many problems with that.
Oopsie daisy. I apologize for this delay. Thank you so much, Philip. Excellent talk. Let's give a warm hand. And look at that. Who might that be? Oh my God, it's you. Thank you so much. This is your tiny present from us for participation. Thank you so much.
Awesome, thank you.
Thank you. Guys, find Philip to talk more about Minerva. And we are entering the coffee break. You have program outside. There is Dodgem and Tiny Railway. You also have coffee, stretch your legs, and we will be back here at 11:55. Don't forget that you can get stamps on your badge to participate in the sponsor raffle. So you have now 20 minutes to do that.